How is nuclear energy produced?
Well, nuclear energy uses uranium, basically. And you take uranium and you put it into little rods, and you let the uranium, which is radioactive, which means it's giving off neutrons, okay? You put those uranium rods in a reactor, and you run water around it. And that water gets heated up by the uranium, goes to a turbine that turns and makes electricity. It's the same process to make electricity with uranium or a nuclear reactor as it is with oil or coal or even wood. Basically, you're heating up water, turning a turbine, making electricity. In the case of nuclear power, it's just that you're using a uranium source instead of coal, oil, natural gas, or wood.
Tell us, what is fission exactly, without getting too scientific on us?
Yeah, fission is a simple thing. You have uranium, which you dig up out of the ground, and a natural element. You purify it a little bit, and then you stick uranium next to uranium, and the neutrons that come flying out of there, which makes it dangerous. That's why it's radioactive. It's letting stuff loose. And so the neutrons go from one piece of uranium to another and get it all excited, okay? And that's what fission is, and it makes it give off more neutrons. It would be like if you had a tough guy go in a room with a bunch of other tough guys, and they start hitting and beating on each other, and it just spreads, and then you have a riot. That's fission, okay? So the uranium is exciting other uranium into being radioactive. And if you control it, like they're doing, you can heat up water very efficiently. You can heat up water with, like I said, these other things like oil and coal, or you can do it with uranium.
Which is much more efficient.
It is more efficient until something goes wrong.
Japan gets something like 30% of its
35%
of its electricity from nuclear power. Is that right?
That's right. Japan gets 35% of their electricity from nuclear power, which means they're in trouble right now because they have a number of those units are shut down.
What happens in a meltdown?
That's when this whole story took a turn, a dramatic turn, is when the Japanese officials started using the term meltdown. A meltdown, like at Chernobyl, I spent 10 years going in and out of Chernobyl, so I know what a meltdown is and what the effects of it are. At Chernobyl, what happened was you had all these fuel rods, okay, and they tried to stop the reaction by dropping control rods next to them. That's how you stop a nuclear reactor. If you go to your stove and you want to turn your stove off, you turn the knob, you turn off the stove. The way you turn off a nuclear reactor is somebody turns a knob and they put control rods next to the uranium rods.
Are those cooling rods?
No. What they are is that's a different process. These rods just stop the
fission.
The fission. They stop the uranium from playing with each other, okay? They stop them from interacting with each other, and so it just calms it down. Now, the problem is it takes weeks or even months for that stove to cool off. When you turn your stove off at home, you know, it cools off in a short period of time. You turn off a nuclear reactor by putting those rods in there, it takes weeks or months for it to cool off. So you have to keep water around it all the time during that process when it's turning off.
Around the outside of the rods?
Around the outside of the rods, right. Not in the rods, but around the outside of the rods. You have to keep that water circulating and taking that heat off. Now, that water going around the reactor, it's doing that. Remember, we had water going around the reactor. You take that heat, you take it away, you turn a steam turbine, and you got electricity. Well, now you just want to get that heat out of there, because if you don't, you start getting a meltdown. As the water starts uncovering those rods, they start melting. They're really, really hot. Now, at Chernobyl, the problem is when they tried to drop the rods in there to turn the oven off, they didn't go in. They had a bad reactor design. We told them, and there are a lot of details of that, but the rods never went in, so they couldn't turn the oven off. Okay, they couldn't turn this nuclear reactor off.
It exploded.
It melted down. Yeah, it melted down. They had a steam explosion like they had here. Now, see, they had an explosion at Chernobyl. They had an explosion in Japan. The big difference was the Japanese got those rods in right away. That's the good news. And that's what separates the Japanese situation from the Chernobyl situation. They got the rods in right away. The minute the ground started shaking, they dropped the rods in, turned the ovens off. Now, at Chernobyl, the reactor blew up. They didn't have the rods in, and all those rods melted down and then caught on fire. And they blew up and went into the atmosphere. Okay?
So that is tons of radioactive material just disseminating in the air.
100 times as much radioactivity as Hiroshima and Nagasaki atomic bombs combined went up into the air at Chernobyl. That's a lot of radioactivity and went into the air. That's the key here. Here's the differences between Japan and Chernobyl right now. At Chernobyl, it was a complete meltdown. It went up into the air. In Japan, we don't think it's completely melted down because they got the rods in. So what you probably had was a partial meltdown. When that water started going down, you see, normally you just keep circulating the water. Well, there's no electricity because they had an earthquake. Okay, your backup system should have kicked in. They have all these generators. Didn't happen. In 3 of the reactors, at least, 11 reactors were shut down. They got the rods in there. Okay? But 3 of them, as it turned out, they didn't get backup generation. So the water is not circulating the way it should. And so the water levels start going down. They have now admitted that they've uncovered some of these reactor rods. Well, the best analogy way to think about this is a candle. You take candles, let's think you got 40 candles together, and you're burning all the candles, and they melt from the top down. And you decide, okay, we've had enough fun at dinner tonight. We blow the candles out, okay? And they're just partially melted. That's probably what happened here. The water uncovered these reactor rods, and they melted from the top. And then wherever the water stopped,
to the surface of the water,
or maybe near it, okay? And until as long as you're moving that heat out of there, it'll be all right. So what is almost certainly what happened is they had a partial meltdown, and from the top down.
What I don't understand is if these reactors are they contain all this fission activity and radioactive material, how does the radioactive material escape from the reactor and get into the atmosphere?
Yeah, that's a good question. So when you really have a reactor inside a containment vessel. So there's 2 different lines of defense. The reactor is down here. The reactor rods are inside this very big containment area. Then you've got a containment vessel around it where you have all sorts of other activities going on with pipes and pumps and things. That's where the explosion was. These 2 explosions were not in the reactor core where the reactor rods are. The explosion was in that outer containment area. What happened was their backup systems were going down on 3 of these reactors. So they were going back to batteries. They were trying to keep these reactors going on batteries where they keep the water circulating through there. Well, apparently they failed, and so they had to start putting seawater in. That's like the Hail Mary, where you're just really desperate now. And so it was a lot better than letting the core get uncovered. So they poured seawater in there. Well, seawater is H2O, and that H is hydrogen. And so they got all this hydrogen built up, and hydrogen is very flammable. And they had an explosion. And it's happened twice now. And so the explosion was up in that containment vessel, not in the reactor core, but in the containment vessel around it.
So it allowed the radioactive material to escape?
Now that's the key. It was only a minor amount of radioactivity. Most of the radioactivity is still in that core. The containment vessel only had a little bit of radioactivity in it. Okay. Now we're getting all sorts of measurements that they say and they're giving to us that are outside the reactor now. Measurements, I won't give the numbers here, but like getting a normal dose of radioactivity a person gets in a year that you or I get in a year in an hour. Now, that's a pretty good multiplication of radiation, but it's still nothing next to what you would get or you would have to get in order to get sick. Okay, it's like probably 1,000 times still lower than what happened at Chernobyl, where people got very sick. Okay.
So let's just talk about Japan for a second. Then I want to ask you about Chernobyl. The amount of radiation that's emanating from these reactors, how far a radius will it reach, and how dangerous is it?
Well, right now we think most of the radioactivity that's been getting out of these reactors is through steam releases. The steam kept building up and building up in these malfunctioning reactors, so they had to get rid of it. You have to do that.
Or well, otherwise the whole thing will explode?
Well, the whole thing will go. And so it's the correct thing to do at this point. We like to avoid those kind of procedures here in the United States or in any nuclear reactor. But if you get to the point where you have to have, you've got to do something. If the steam buildup is occurring, you've got to vent it. That's where your radioactivity is coming out, because they've got to get that steam out of there. It's going to carry a few radionuclides with it. So far, at least the numbers we're seeing, they're relatively low levels. Now, there were enough to cause sailors on the Ronald Reagan aircraft carrier to have to be decontaminated. 17 of them had to be decontaminated today.
And how far away was that?
It was quite some distance away. As a matter of fact, the Ronald Reagan had already veered away from the coast, anticipating something like this happening. My expectation is they're starting to lose a little confidence in these reactors since they've had 2 hydrogen gas explosions. Now, it's important to note that those explosions that occurred were not radioactive gas explosions. They were hydrogen explosions because that hydrogen built up in that second containment vessel around the outside. And it just detonated because hydrogen is flammable. The radioactivity that we're seeing is probably mostly from the steam releases, okay, which come out of the lower vessel as well as out of the outer vessel.
And those are intentional releases to keep the whole thing from exploding? That's
correct. Those are intentional releases to keep those vessels from completely exploding and releasing a lot more like a Chernobyl-style disaster.
Let's talk about what happened in Chernobyl, Cham. So in Chernobyl, the whole darn thing exploded, blew up, right?
Yes.
So that sent, as we said, just tons of radioactive material into the air. How far did that radioactivity spread, and what were the health effects at Chernobyl?
Yeah. At Chernobyl, they had a bad reactor design at Chernobyl, and they also had human error. So that's the reason Chernobyl melted down, was a bad reactor design, human error. They didn't tell the public for 3 days. The Soviet government didn't tell anybody. And so people in the town of Pripyat stood on their balconies and watched the reactor burn for 3 days. Pripyat is now the largest abandoned city in the world. So what happened was they've rushed firefighters in there to put this fire out. Unlike American nuclear reactors, and unlike Japanese nuclear reactors, the Russians, or the Soviets, didn't have big concrete containment domes over their reactor. We have $1 billion concrete containment domes over them. So do the Japanese. That is what has saved them so far, is that they have very strong containment domes which have withstood some pretty hard beating so far. The Russians didn't have that. So when they made their mistake with a bad reactor design, they melted down the core completely. It melted down, and then it blew up, and so it caught fire, and so they had a perfect storm where they didn't have it contained, and they essentially burned off most of the reactor fuel into the air over several days. They then maximized the exposure of their population by not telling them. Okay? That's the difference between the old Soviet communist system and our system. We have an environmental movement. Okay? We have a checks and balances. We have political parties vying with each other, and we have citizens vying with the government as well. And they didn't have that in the Soviet system. And so there were no checks and balances, and so they unleashed 100 times as much radioactivity as Hiroshima and Nagasaki atomic bombs combined. The health effects. There were dozens of firemen who rushed to the accident, risked their lives, putting the fire out, or trying to put the fire out, and they died of short-term, what we call the prodromal syndrome, the radiation syndrome, the very unpleasant way to go with symptoms that are very unpleasant, and I'll avoid here. But they died
Tell me,
within...
we won't use them, but I'm just curious. What is it, just basically cook your body?
Well, what happens is...
Like being in a microwave?
No. What happens is the fastest growing cells of your body go first, okay? So that means your hair, as well as your gastrointestinal lining and your mucosal linings in the various parts of your body, so that you start bleeding from various orifices, and you have nausea, vomiting, diarrhea, a shutdown of the blood system. It shuts down. There's extreme headaches, extreme nausea, and it's not curable, okay? It's a bad way to go. And they had dozens of people that died from that. They then, at Chernobyl, they then brought a bunch of workers in and built a sarcophagus, they called it, that they built around the reactor. Big, huge thing. They built it in a hurry. They managed to expose a whole lot of people to radiation. Then they took hundreds of thousands of workers. We now call them liquidators, not like Schwarzenegger and Terminator, but liquidators. And they sent them out there to gather up all the radioactive dust and particles, and they exposed thousands more people. It was a fiasco. We learned a lot about how not to handle a radiation disaster, and that's why I was involved. I wanted to see what happens when there really is a meltdown so we can avoid it.
What about just average citizens in the town? What happened to them?
Well, they were 11,000 children have gotten thyroid cancer as a result of this, which is very interesting because after 3 days, the Soviet government announced that this had occurred, and they rushed out and they gave those iodide tablets to all the children. Radioactive iodide seeks the thyroid. It's the only organ of the body that will use iodide. So that radioactive iodide just goes right for it. If you get an iodide tablet quickly, you can block it. It'd be like your teenagers vying for a position in the garage. You know, the first person gets their car in there, blocks it up, and you can't get in. And so that's what happens. You can take regular iodide, block it, and then the radioactive iodide can't bind. The only problem is we learned from Chernobyl that the iodide's not effective after 4 hours. And they were giving it to them 3 days later. So they gave the drug way too late. And so now you have 11,000 children that got thyroid cancer. There are many other people that had various autoimmune responses, all sorts of immunological problems. The one interesting thing, and it's something to really take note, there were no birth defects, which I was sort of expecting, and many others. We tracked this very closely, and it didn't happen. So there was not all bad news. There was good news. There were no birth defects as a result of this intensive radiation exposure, which is something for us to think about, because that's at least one less thing to worry about.
What about other cancers? Were there other cancers?
Amazingly enough, they have not showed up yet. There's been a very vigorous debate in the scientific community about this. Ukrainian scientists, for instance, for a long time debated with the UN, with the United Nations, the International Atomic Energy Agency, the IAEA, who said it wasn't occurring. And right now, the scientific consensus seems to be that there were not a large number of cancers, other than the thyroid cancers that resulted in this. Now, I was tasked by the United Nations to try to figure out what we learned from Chernobyl about a nuclear war. And my conclusions, and they've agreed with them, is that that may not hold true for nuclear war. Probably the birth defects is true. There probably are not going to be birth defects. That's the good news. Cancers, I believe if you get more radioactivity out there, we probably will see them, okay, later on, because we saw them after Hiroshima and Nagasaki.
Chernobyl is still an extremely dangerous place, isn't it?
It is. I've been there many times. I've led a dozen expeditions, scientific expeditions, into the most highly contaminated areas there. And there are areas that are still quite dangerous, yes. You wouldn't want to go in. There are others that are starting to become livable again, and people have moved back into them.
Someone told me there was a 16-mile radius around the site of the Chernobyl explosion that's still quite dangerous.
They called it the exclusion zone, or just simply the zone. And there's fences around it and guards. keeping people out of the most highly contaminated areas. And
even today?
Even today.
I know you've said you believe the situation in Japan will fall somewhere between 3 Mile Island and Chernobyl. What do you mean by that?
Well, right now, the Japanese situation is rated below 3 Mile Island, okay? But that's because things haven't developed along like they could. The difference between 3 Mile Island and the Japanese situation is that 3 Mile Island was in a normal operating country. The Japanese reactors that are malfunctioning are right in the middle of a disaster. And that's the issue. That's the difference. They're in a devastated area. So there's economic and social, and you cannot overestimate the mental health aspects of this disaster that will impact the Japanese for many years to come. So that's why I put it not necessarily in a radiological sense, but in a disaster sense. It is far greater than 3 Mile Island because you've got all this destruction around it that just augments it. Particularly, you just can't. I tell you, until you've been in disasters, and I know, you know, as a professional media personality, you see disasters frequently. The mental health aspect of these things cannot be downplayed. It really has a lingering effect. Katrina in New Orleans. I lived in New Orleans for a number of years when I was a young person and younger, and that city has not recovered. The vivid effects there, mentally, economically, socially. It'll be like that probably in northern Japan for quite some time.
Japan is known for its preparedness and even sort of a very sophisticated early detection system, right? Didn't they have 30 minutes to warn people about the tsunami?
They did.
It doesn't seem very long, but it's longer than...
Oh, it's longer than we have.
Yeah.
We don't have that system in place.
I know.
Yeah.
Because it hasn't been funded, I'm told. Properly.
Yes, it hasn't been funded. Now, I would have to say the Japanese have more of a need for it than we do. But they showed what you could do. The death rate of thousands, which continually goes up each day, would have been higher, much higher, if they hadn't had that early warning system.
Having said that, why didn't the backup systems for these nuclear reactors work more effectively?
You've hit upon probably the most compelling and negative aspect of this to me as a preparedness person and to anybody looking on and living in that area. I am really shaken a bit by it. These are simple technologies. A diesel generator, and you hook it up and you run a pump and you pump water in and out. It's not highly complex. We now, we're told today, and the latest news is that one of the problems they're having there now is because one of the generators they did have operating ran out of gas, ran out of fuel. And these are simple things, and you just can't afford to make mistakes like that. And that shakes me a bit with this. I do have an enormous respect for the Japanese in earthquake response. They even design their cities with buildings as fire breaks to keep mass fires from the interior of the city getting to the suburbs. I mean, that's a level of preparedness we don't do in this country. Yet, for all that complexity and all that emphasis, to let a simple thing like keeping a diesel generator operating, that's compelling and disturbing.
There are 104 nuclear reactors here in the United States. Could this happen here?
Could this happen here? We have a very strong culture of preparedness in the nuclear power industry here. As I said earlier, we have an environmental movement in this country, and we have an active political process, and that has kept the nuclear power industry on their toes. Okay, like I said, there hasn't even been a new nuclear power generator approved until recently for decades. That's really kept the existing nuclear power industry on their toes, focused on keeping people happy. If you ask them, they'll tell you they're overregulated. But the end result of that is that there has been a very strong culture of preparedness in the nuclear power industry. That said, I have to say that the collapse of the simple things on the Japanese front does rattle my cage some. I think in the long run, this can be addressed here. Obviously, these questions are going to be asked. Senator Lieberman today said that he's going to be looking into this in the Homeland Security Committee. I think the questions need to be asked. My confidence in the nuclear power industry remains high. If you ask if you think this will happen here, I would say based upon our preparedness and on expertise and equipment, personnel, no, it won't happen here. But when you take a look at the simple things going wrong over there in Japan, like a generator, not getting a generator where it needed to be, that's disturbing. And it does rattle your confidence.
Thank you very much. This was really informative and helpful, and we appreciate it.
Thank you, Katie.